Algebraic and graphical representation of direct proportion. Okay, if y is directly proportional to x, then algebraic and graphical representations of direct proportion 1.2 unit. If y is directly proportional to x, then y by x equals k, or y equals kx, where k is a constant and cannot be 0. Here one condition is given, that the value of k cannot be 0 because if you incorporate 0 in the equation y by x equals k, you will get y equals to 0. That cannot be possible because this is a direct proportion. Y should be changed with the ratio of x, with the same ratio of x, so y cannot be 0. Now come to the thinking time. If we substitute k equals 0 into y equals kx, y equals kx is the equation of direct proportion. It represents the relationship between y and x, and instead of proportional sign, we get a constant k. What can we say about the relationship between x and y? Let's explain us this answer. Okay, the answer is about the thinking time. If we assume k equals 0, then what will happen? If we substitute k equals 0 into y equals k by x, then we will get x equals 0. This implies that for all values of x and y equals 0, we will get 0. But it can't be possible. But y cannot be inversely proportional to x in this case. So if you incorporate a k equals 0 into y equals k over x, you will get y equals 0. This cannot be possible for direct proportion because of y should be changed with the ratio of x. So we can't apply over here the value of kx 0, but here k is a constant. Any values, integer values, can be calculated over here for k. 1, 2, 3, 4, thus the integers, but k cannot be 0. This is the condition for the direct proportion of y equals kx.